My name is Srilakshmi. My topic is optimize labor allocation in a construction company using a simplex method. Here is the introduction. Efficient labor allocation is a crucial for reducing cost and increasing productivity in construction projects. The simplex method offers a systematic approach to solving complex linear programming problems. This presentation explores how to apply the simplex to optimize labor distribution in a construction company. The proper allocation labor ensures timely project completion and resource utilization. Over or underutilizing workers can lead to increasing cost and project delays. Optimizing labor helps balance the workload, reduce waste, and improve overall efficiency. The overview of linear programming. Linear programming involves maximizing or minimizing a linear object's function subject to constraints. It provides a mathematical framework for decision making in resource allocation. The simplex method is a widely used algorithm for solving linear programming problems efficiently. Problem statement in construction context. The goal is to determine the optimal number of workers needed for different tasks. Constraints include labor availability, project deadlines, and budget limits. The objective is to minimize total labor cost while meeting project requirements. Defining decision variables. Decision variables represent the number of workers assigned to each task. For example, X1 could denote carpenters and X2 could denote electricians. As accurate decision variables are essential for modeling the problem correctly. The formulating the function. The objective function typically minimizes total labor cost, minimize z is equals to C1. Establishing constraints. Constraints ensure the solution adheres to resource limits and project requirements. Examples include availability of workers and task completion deadlines. Constraints are expressed as linear inequalities or equations involving decision variables. Example constraints in construction: labor availability x1 less than or equals to carpenters available. Task requirements is x1 plus x2 greater than or equal to minimum workers needed for task completion. Budget limitations: total labor cost less than or equal to allocated budget. Setting up the LP model. Combine the objective function constraints into the comprehensive linear programming model. Ensure all constraints are linear and feasible solutions exist. A clear LP model received for construction allocation process problems. How to put it into a standard form for a simplex problem. A worked numerical example. Construction frames that Optimization of resource allocation in construction using the simplex method is an effective mathematical approach to maximize or profit or minimize total cost under limited resources. In any construction frame, several projects or activities such as residential, commercial, and infrastructure works compete for the same limited resources like labor, machinery, materials, and budget. The simplex method helps management determine how much of each activity to perform so that total profit is highest without exceeding available resources. The problem is first formulated as a linear programming model where each activity is represented by a decision variable. The objective function expresses the total profit or cost as a linear combination of these variables and the constants present the available limits or of resources. For example, if labor hours, machinery hours, and material budgets are limited, each project consumes a specific amount of these resources per unit output, and these consumption rates are used as coefficients in the constants. Once the model is formulated, the constants are converted to equality form by adding slack variables, and the simplex method is applied systematically to move from one feasible solution to another while improving the objective function at each step. The process continues until an optimal solution is reached. One where no further improvements is possible, the final solution provides the optimal allocation of labor, machinery, and material resource among competing construction activities. For instance, in a sample program problem, a company may find that assigning 32 labor units to residential work and 12 to commercial work yields to the maximum profit while using all available labor and material budgets efficiently. The simplex method also provide shadow prices while indicate how much additional profit can be gained if more resources like labor or budget become available. This analysis helps managers identify bottleneck resources and plan better for future expansions. The method supports decisions such as whether to hire more workers, rent extra machines, or shift resources between the projects. It ensures that no resource remains underutilized or wasted. The simplex approach can handle large complex problem project data and give precise numerical results compared to guesswork or manual allocation. It allows for sensitive analysis where managers can study the effect or change in cost, profit, or resource availability without solving the model again. In summary, using the simplex method in construction resource allocation enables the company to operate more efficiently, reduce the idle resources, control cost, and achieve maximum profitability while maintaining all project constraints. Applying the simplex method, convert the LP model into standard form with slack variables. Use the simplex algorithm to iteratively improve solutions toward optimally. The process continues until no further improvement is possible. Interpreting the simplex table, the table displays variables, coefficients, and solutions at each iteration. Pivot operations identify entering and leaving variables to improve the objective. The final table indicates the optimal labor allocation. Example solution results. The optimal solution specifies the number of workers for each task. It minimizes total labor cost while satisfying all constraints. The result guide managers in efficient labor deployment. Practical implementation considerations, accurate data collection on wages, task durations, and resource availability is essential. Regularly updating the model helps accommodate project changes. Combining simplex results with managerial judgment enhances decision making. Benefits of using simplex in construction: cost savings through optimized labor use and resource allocation, improved project scheduling and timely completion, better responsiveness to project constraints and uncertainties. Limitations and challenges: Linear programming assumes linear relationships, which may oversimplify real world complexities. Data accuracy is critical. Errors can lead to suboptimal solutions. Implementing solutions require coordination and communication across teams. The simplex method is a powerful tool for optimizing labor in construction projects. Future development may involve combining LP with more optimization techniques for more complex scenarios. Integrating this approach with the project management software can enhance efficiency. Find a problem, then define your close, then make a change, quantify problems, and keep refining, and then again find a problem. Here is a conclusion. The simplex method is the powerful tool for optimizing labor in construction projects. Integrating these approach with the project management software can enhance efficiency. Future developments may involve combining LP with our other optimization techniques for more complex scenarios. Thank you.